In this video, we will be talking about daytime warming. We'll be talking about different types of situation, and from the situation, we have to have an understanding how the daytime warming happens in terms of the climate and weather situation. So I would strongly recommend you to pause this video and listen if you are having little trouble understanding. Okay, in a way, each sunny day is like a tiny season as the air goes through a daily cycle of warming and cooling. The air warms during the morning hour as the sun gradually rises higher in the sky, spreading a blanket of heat energy over the ground. The sun reaches its highest point around the noon 12 o'clock, after which it begins its slow journey towards the western horizon and path to the sunset. It is around noon when the Earth's surface received the most intense solar ray. However, somewhat surprisingly, the noontime is usually not the warmest part of the day. Rather, the air continues to be heated, often reaching a maximum temperature little after a couple of hours or 2 or 4 after the afternoon. It's become maximum temperature. To find out the way this lag in temperature occur, we need to examine a shallow layer of air in contact with the ground. That's we'll be talking. Daytime warming. As the sun rises in the morning, sunlight warms the ground for sure, and the ground warms the air in contact, that's for sure, with its by the process of heat conduction. We know about the conduction. However, the air is actually a poor heat conductor, and that is the process only takes place within a few centimeters of the ground. As the sun rises higher in the sky, the air in contact with the ground become warmer, and there is existing a thermal boundary separating the hot surface air from the slightly cooler air above. Given their random motions, some air molecule will cross this boundary. The hot molecule below bring greater kinetic energy to the colder air, and the cool molecule above bring a deficit of energy to the hot surface air. Well, on a windless day, we are considering on a windless day, this form of heat exchange is slow, and a substantial temperature difference usually exists between the air at the ground level and the air directly above it. This explains actually why runner on a clear windless summer afternoon may have experienced air temperature more when it's running. Anyway, that's not a very good example. Anyway, near the surface, convection begins. The air, the rising air bubbles, we also call the rising air bubbles is thermals. These thermals helps to redistribute heat. In a calm weather, there these thermals are small and do not effectively mix the air near the surface. Well, therefore, large vertical temperature gradient can exist. What does temperature gradient mean? Temperature gradient is the temperature difference. Okay. But what happened in the other situation? On a windy day, turbulence can mix with hot surface air and with cooler air above. This form of mechanical steering, sometimes called forced convection, helps the thermal to transfer heat away from the surface more efficiently. Therefore, on a sunny, windy day, the molecules near the surface are more quickly carried away than on a sunny, calm day. Well, We can now see why the warmest part of the day is usually in the afternoon. Around noon at 12 o'clock, the sun's rays are most intense. Incoming solar radiation decreases in intensity after the afternoon, but for a time it still exceeds outgoing heat energy from the surface for a little more time. It's called infrared terrestrial radiation. This situation yields actually some amount of surplus energy for 2 hours to 4 hours after the afternoon. Well, and this is the reason the maximum solar heating and the time of maximum air temperature um, became the maximum air temperature at that time. So our maximum air temperature will not be right after the afternoon. That would be in 2 hours or 4 hours later, the afternoon, due to the terrestrial radiation. At the same time, solar energy and the terrestrial radiation acting. If you are looking at slide at the picture at C, you'll be understanding this graph more frequently. The exact time of this highest temperature reading varies somewhat, but the summer sky remains cold free after the afternoon. The maximum temperature may occur sometime between 3 p.m. to 5 p.m. You are now looking at uh, C, the picture C here. Well, adjacent some other situations. So adjacent to the large body of water, what happened? Cooled air moving inland can modify the rhythm of temperature changes such that the warmest part of the day occur at the noon or little before. In the winter, the atmospheric storm circulating warm air northward can even cause the highest temperature to occur at night. Just how the warm the air becomes depends on such factor. Some other factors like type of soil and its moisture content and how this vegetation cover is present there. When the soil is a poor heat conductor and loosely packed sand in, the heat does not readily transfer into the ground. This allows surface layer to reach a higher temperature, permitting more energy to warm the air above, right above. On the other hand, if the soil is moist or covered with a lot of vegetation, so what will happen? It will not heat up that much, right? Leaving the heat to the air. As you might expect, the highest summer temperature usually occur over the desert region because the adjacent to the surface actually heated up, coupled with incoming solar radiation and also infrared thermal radiation, terrestrial radiation. So this would be our daytime warming in different states. So for now, we understood the daytime warming depends on some situation. Number one, it depends on incoming solar radiation for sure. Number two, it also depends on um, the terrestrial radiation. And we know that the maximum temperature in a open sunny day, or not windy open sunny day, so we have maximum temperature after the afternoon. Those are the most important information from here. And also we have other factors that has effect in the daytime warming. That's type of soil, water body around it, and vegetation, everything. So I hope that you would understand the daytime warming situation here. Thank you.